Okay, so let's talk about using slope to graph our linear equations. Alright, so on here we are going to sketch the line that has a slope of m equals -2/5 and a y-intercept of 0, 3. So start at your y-intercept. So I'm going to go up to 0, 3. The y-axis is the vertical axis. So I'm going to put a dot right here. From that dot, you're going to do your slope. Now, a slope of -2/5 means -2/5, or it could mean 2/5, which in the top case, this would mean down 2, right 5. In this case, on the bottom, it would mean up 2, left 5. I'm going to show you that both of those are the exact same line. So let's do this one first. Down 2, right 5. Down 2, 1, 2, 3, 4, 5. Put a dot. Now, I could have done the slope with the negative in the denominator. So that would mean from my starting point of 0, 3, I would go up 2 and left 5. Okay, I'm going to grab a sheet of paper here and use it as a straight edge and, connect my dots. Oh, that's terrible. Sorry. That's even worse. Okay, we're going to pretend like it hits all those dots. So, there's your line with a slope of -2/5 and a y-intercept of 0, 3. Okay, so it says here, for a linear equation of the form y equals mx plus b, it says that your slope is m and your y-intercept is your b. And this equation is in slope-intercept form. Okay, these are just some instructions on how to graph an equation that's in slope-intercept form. If I were taking notes, this is probably what I would write down. Okay, so now we're going to sketch the graph of y equals -3/4 x plus 4. So you need two pieces of information. You need your slope, and look, our slope is staring at us. It's this number right here, -3/4. Our y-intercept, our b, is 0, 4. So this right here is our starting point. Okay, so on my y-axis, I'm going to go up to 4 and put a dot. From that dot, I am going to go, if my negative is on top, that means down 3, right 4, or if my negative is on bottom, in the denominator, that means up 3, left 4. So, down 3, right 4, 1, 2, 3, 1, 2, 3, 4, or up 3, left 4. Okay, let me do my best to connect these dots. Oh, I cannot do it to save my life. There we go. Sorry about that. Okay. There we go. Alright, so there's our line of y equals -3/4 x plus 4. Okay, so the percentages of U.S. food sales that are organic products are shown in the table for various years. Let P be the percentage of U.S. food sales that are organic products at T years. So T and P. and it says T years since 2000. So 2000 would be year 0. 2002 is 2. Here's 4. Here's 6. Here's 8. Here's 10. And so then they also give us a reasonable model. So by reasonable model, that means that they're giving us the equation of the line. So the thing is, this model's slope is in decimal form. Everybody needs to be comfortable with turning a decimal into a fraction. It's so much easier to graph. So P is equal to 0.3 is the same thing as 3 over 10 T plus 1.1. So if I were graphing this, I would go to my y-intercept of 0, 1.1, and then from there I would go up 3, right 10. So let me show you this graph. I'm going to let the computer or the textbook actually show us the graph. It can do it so much neater than I can by hand. And then we're going to talk about number 2 whenever we do the graph. Okay. So again, they turned it from 0.3 to 3 over 10. So our rise is 3, our run is 10. So here is the graph of this. Now let's go back and read that second question. The second question says, predict when 6.2% of food sales will be organic products. So we're going to go to this graph, and I'm going to go up here just a little bit above 6, about 6.2, and I'm going to go over here to where that meets the line at, and it meets it right here. So we go down and we take a look at what year goes with that. Well, year 17 goes with that. So that's 17 years since 2000. So this is saying that in 2017, they predict that 6.2% of food sales will be organic. Okay, so on this problem it says find an equation of the line that has slope of 2/3 and a y-intercept of 0, -5. Remember, if I use this, y equals mx plus b, m is my slope and b is my y-intercept. Okay, there's a couple of different ways I could write this equation. I could say that y is equal to 2/3. You always put your slope in. Don't forget your x. And I could say plus -5, or I could say y is equal to 2/3 x minus 5. These are the same equations. They mean the same thing. They both have a y-intercept of 0, -5, and so you could write it either way. I prefer the one on bottom, but this top one is not wrong either. Okay, so to find an equation of a line from a graph, you need to determine the slope and the y-intercept. And once you know those two pieces of information, then you can find the equation once you're given the graph. So let's take a look at that. All right, so here's a graph. So you need two pieces of information. You need the slope and you need the y-intercept. The y-intercept is pretty easy on this one. We can take a look at that and we can tell that that y-intercept is at 0, -1. The slope is a little bit tougher. So notice how I put a dot right there on that line. I need to find another dot that is a good place. I could use this one right here, or I could use this one up here. Either way, I should get the same slope. So if I use, let's say, the pink one, I'm going to use these two dots. So I count up from my lowest point, up 1, 2, so my top number is 2, my numerator is 2. From there I have to go left. Left is negative. 1, 2, 3. So -2/3. I can't write again. I might as well just redo the whole thing. Okay, -2/3. There we go. Okay, so now I can write the equation of the line. Y is equal to -2/3 x minus 1. That's the equation of that line right there. Okay, so now let's talk about parallel lines. If two lines never ever cross each other, they are said to be parallel. Also, if two lines have the exact same slopes but different y-intercepts, then they are parallel. So it says here, two distinct lines have equal slopes, then the lines are parallel. All right, so now let's also talk about perpendicular. Now, perpendicular, two lines can cross each other all day long. Those guys cross each other, but they don't create 90-degree angles at the point of intersection. Two lines are considered perpendicular if, when they cross each other, they have to create at least one 90-degree angle. If they create at least one 90-degree angle, guess how many they actually do create? 4 90-degree angles. But all we care about is as long as there's one of them. So they are perpendicular if, when they cross, they create a 90-degree angle. Now, what's interesting about perpendicular lines is that their slopes are opposite reciprocals of each other. Okay, so for example, if I have one line whose slope is 2, then the slope of the line that is perpendicular, this, by the way, the upside down T with a little corner in the middle of it, is the symbol for perpendicular. The slope of the line that is perpendicular to that is opposite, means change your sign, and flip it over is your reciprocal. Okay, so one line would have to have a slope of 2, the other one would have to have a slope of -1/2. So what if I have a line with a slope of -3/5? What is the slope of the line that is perpendicular to it? You change the sign and you flip the fraction. So -3/5 would be one of the slopes, and 5/3 would have to be the slope of the other line. So let's take a look at that. Okay, so let's talk about these. Determine whether the pair of lines is parallel, perpendicular, or neither. So look at number 1. These guys have the same slope. Different y-intercepts, same slope means they are parallel. Look at this one. A slope of 8/5 and a slope of -5/8. They are opposite reciprocals of each other, so that means they are perpendicular. Alrighty, so that's the end of this lesson. I will see you soon.